I am Anil Kumar. Welcome to my series on trigonometry. We'll summarize most of the important concepts learned in this unit. We are talking about area of oblique triangles. The example here is written in a very simplified way, but it can solve the most difficult questions in any exam. We'll review the formulas for area of triangle. When you're given side angle side, the formula is as shown here, half AB sine C. When you are given angle side angle combination, then a very useful formula can be used, A square sine B sine C over 2 sine A. This is not a very popular formula in most of the books. However, when there are multiple choice questions, it is a good idea to apply this formula and get the result in least amount of time. Sine law and cosine law, you know very well, are always used to find the angles and sides in different conditions. Now, to review the concept, we have a very simple worded question which could be actually seen as an application question in most test papers. So, what we have here is ABC is a triangular piece of land. C is 120 meters due west of A. Bearing of angle B is 289 degrees and 307 degrees from A and C respectively. Find area and perimeter of the land. So that's the question for you. Our approach in this particular case is going to be, first, we'll sketch the diagram. I've already shown part of the diagram. However, we still need to find the angles. So we'll work with the bearing angles and see how to calculate angles easily using bearing angles. That is the first part. And the second part, we'll learn how to find the sides. Once you find the sides, that will be using sine law. Since we have a combination here, once you find the angles, we can have one combination of opposite angles, and that will give us the perimeter. And then we'll go in for the area. To find area, as you can see above, we have two formulas. So we'll derive the second formula. So what I'm trying to say here is, this is our formula number 1, and that is our formula number 2. So I'm going to derive the second formula also, as since it is sometimes a question in your book but not a derived formula. So let's begin with the bearing angle itself. So again, the question is here. You have a triangle ABC where C is west. So always we have to consider north, that is the north for us, and C is west. This is east, and clearly that is west. 120 meters, so let me write down 120 meters as the distance between A and C. Bearing of angle B is 289. Now let us see how to calculate the bearing angles. So at point A, we'll draw the north and east and west line. So it is 289 bearing from A and 307 from C. So bearing is an angle which you always measure from north moving clockwise. So that angle we are talking about, and this angle is 289. So how do you find the angle A? This angle. So we'll call this angle A now. So to find angle A, the best way is we can say 289, the bearing angle, minus 270 degrees. So that should give you the angle A, which in this case will be 19 degrees. Is that clear to you? So we got this angle as 19 degrees. Now, let us find the angle at C. So here, what I'm going to do is, we'll again sketch north, south, east, west. And once again, we'll try to calculate the angle in the similar fashion, moving from north to this particular line, BC. And this is 307. So to find the angle, what we will do here is we'll find the external angle C. So let me write down first external angle. External angle C, what I'm trying to say is this angle. Is that clear to you? So the external angle C we're saying is equal to 307 minus 270 degrees. So when you take away, you get 7, and then from 10, when you take away 7, you get 3, so you get 37 degrees. So this angle here is 37 degrees. Clear? Now we can find the inside angle C. So now I'm saying the inside angle C, which is this angle for us, is how much? So I'm writing that as angle C, and is linear pair 180 degrees minus 37 degrees, which is equal to, so when you take away from 10, it is 3, then 7 take away, this is 4, and 143 degrees. So that gives you 143 degrees. Is that clear to you? Correct? Now, angle B, you could calculate using the external angle. So let me again rewrite the formula for external angle. We know external angle C is equal to angle B plus angle A, the remote interior angles. And from here, we can find the angle B. So angle B is equal to exterior angle C take away angle A, which is 37 degrees, take away 19 degrees. And that is equal to 17 take away 9 is 8, and we get 18 degrees. So this angle here is 18 degrees. Does make sense to you? So the method which I have used in this particular case has a uniform steps in it. So if you follow these steps, you can actually work out bearing angles very, very easily. Perfect. So purposely, I've done in this fashion. We are calculating angles taking away 270 degrees if you're working in quadrant 4, right? So this kind of calculation we do quadrant 4. So let me write down a note here. Working in quadrant 4, take away 270 degrees. Is that clear to you? That helps. That helps, right? It's a very important note. And with that, let's move forward. So we already have the angles now, and we can now solve the triangle. We have calculated all the angles. Now it is time to calculate the side lengths of the triangle. We already know that the side CA is 120. So we'll write that down. 120. The angles which we just calculated were, for angle A, it was 19 degrees. This is 19 degrees. Angle B is 18 degrees, very close. And this is 143 degrees. The combination which is known is the combination B with the opposite side. And therefore, we can use the sine law. So we're going to now apply the sine law to find the sides. Since we know this combination, we can find all other sides. Sides are to be calculated, so we are writing the length on the top, which is A over sine A equals to C over sine C, which is equal to B over sine B. So in terms of B, we can now write down both the values. So what we get here is we can from here calculate A will be equals to B over sine B times sine A, and C will be equals to B over sine B over sine C, right? So let's substitute the values. B is 120 sine of 18 degrees times sine of 19 degrees. On the other side, it is 120 over sine of 18 degrees times sine of 143 degrees, correct? Let's use calculator to calculate the answers. 120 times sine of 19 degrees divided by sine of 18 degrees gives us 126.4. We'll just write to one decimal place, 126.4. The units are meters for us. As far as C is concerned, it'd be 120 times sine of 143 divided by sine of 18, and that gives us 233.7 meters. So we get the side lengths now, right? So since we know the side lengths, we can find the perimeter for the given triangle, right? So we can now find the perimeter of the triangle, and we can write down that the perimeter is sum of side lengths, which is 120 is already given to us, plus 126.4 plus 233.7, and that gives you, you can add them up, 7 and 4 is 11, 1, and then we have 4 and 6, 10, 0, again 1, and then we have 4, 5, 6, 7, 8, and then we get 2, 3, and 4. So it comes to 480.1 meters. So that becomes the perimeter for this particular question. Correct? Now, with the known sides, we can always find the area. So we'll move on to the next page, write down the calculated sides, and then work out the area. So 126.4 meters is A. So let me write down that value. So A is 126.4. This is given to us as 120, and C was 233.7. The angles which we calculated were 143. So we can actually use this angle of 143 to find the area, right? Okay. So the area of the triangle, if you are given two sides and an angle in between, as is the situation, is equal to half of the two sides A and B in this case, which is 126.4 times 120 times sine of the angle, which is 143 degrees. Correct? So we can use the calculator to find this answer. 0.5 times 126.4 times 120 times sine of 143. That gives you 4564. approximately meter square. Is that clear to you? So that is how, using the given formula, which is right there, easily we can find the area of the triangle. Is that clear to you? Right? Now, let's also develop another formula because we had to find all the sides. Now let's develop another formula to calculate if we know the other combinations. We knew this combination 120 was the given length for us, and we calculated this angle as 143. We calculated this angle as 90 degrees and the other angle as 18 degrees. Now let us say that it is known to you only these sides and angles, which is we're looking for ASA. We have these two angles and the side known to us. In that case, how will you find the formula? Well, it is the combination of the previous one, which is we know if we know two sides and an angle in between, in that case, area is equal to half of AB sine C. Correct? Now, in our case, what is given to us is angle B and A. So, what we could do is use the sine law to replace A with equivalent to B. So, we could always say that A over sine A is equal to B over sine B. And from here, we can write down that A is equal to B times sine A over sine B. Is that clear to you? Now, if I substitute this value of A here, then what happens? In that case, we get a new formula for area. And let me rewrite this as equal to half of, so instead of A, I'm writing B sine A over sine B. We already have sine C here. See, what do we get? So we get the area in terms of all the angles and the known side. So the formula here will be, and already we have to now multiply by B also. I missed this B here, right? So it times B times sine B. That is what we get. So we could write this as half B squared sine A sine C over sine B. Now this is a great formula which we discussed, rather we shared with you in the beginning. The second formula, right? So the known side square comes on the numerator and the angle with sine comes in the denominator. That is what we got. This time the known side is B, and therefore we got B squared. Now we can substitute and calculate our values. So we have derived the formula. Let me now substitute the values. We got half of B square, which is 120, sine of A, which is 19, sine of C, which is 143 degrees, divided by sine of 18 degrees. Let's calculate this and check our result. So half times 120 squared times sine of 19 degrees times sine of 143 degrees divided by sine of 18 degrees gives us 4565. So we get exactly the same answer, which is 4565, right? Units meter square. Do you see that part? So we got exactly the same answer. However, this is a shortcut for many test problems. Correct? So let's summarize our results. So in this case, whenever you have a problem like this, first step is to calculate the angles. Remember, if you are in quadrant 4, then bearing angle minus 270 degrees is a key. Correct? Second step is apply sine law. Find sides. Keep side length in numerator. And the third and final step is apply area formula. So there could be two different formulas depending on you have side angle side case or you have angle side angle case. So you have now two formulas to work with. You could use any of these formulas, and that should help you to provide a quick solution to your questions. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.